You know, deep in the vast wetlands of the Great Lakes, there's this incredible treasure that grows right on the water. It's called Manoomin, or wild rice. For centuries, it's been a cornerstone for, well, for everything, the ecosystem and the Anishinaabe people. But today, this ancient plant is sending out a really desperate warning.
So get this, in the St. Louis River estuary, right at the head of Lake Superior, over 90% of the historic wild rice beds have just vanished. And this is in the last 50 years. What was once a huge, sprawling habitat of nearly 1,000 acres is now down to just a few scattered patches. And this isn't some slow, gentle decline. It is a catastrophic collapse.
So what in the world is going on here? That's the central mystery we're going to dig into in this explainer. Why is this absolutely vital plant disappearing so fast? Well, scientists have a new theory, and it doesn't point to a single culprit, but to a kind of conspiracy of forces that are pushing Manoomin right over a cliff. To really get why this is such a big deal, you've got to understand that Manoomin is playing two huge roles at once. For the Anishinaabe people, it's what's known as a cultural keystone. It's totally central to their identity, their rights, their spirituality. And for the estuary itself, it's a biophysical keystone, providing food and a home for countless birds and fish. When it disappears, it leaves this massive hole in the entire web of life.
And here's the thing. Manoomin is, well, it's kind of picky. It's super sensitive. It has this very specific checklist of things it needs to survive. Think of it like a delicate instrument that has to be tuned perfectly. It needs the water to be just the right depth, with a gentle flow, not too many nutrients, and this is the big one, the water levels have to be stable. If any one of those things gets out of whack, it can mean big trouble.
Okay, so let's get into the main theory here. And what's really fascinating is that scientists don't think it's a single smoking gun. Instead, the idea points to a triad of stressors. 3 different pressures that, when they combine, create a fatal cocktail for wild rice. They're pushing it past a point of no return.
Now, this is a really crucial point. We often call a species like this an indicator. You know, if it's there, things are good. But this new theory reframes Manoomin as a sentinel. And there's a big difference. A sentinel is more active. It's an early warning system. Its sudden disappearance is like a blaring alarm that the entire ecosystem is getting dangerously close to a tipping point.
So who are these 3 prime suspects in our little environmental mystery? First, we've got increasingly extreme and chaotic water levels. Second, elevated water temperatures, mostly thanks to a warming climate. And third, these big pulses of nutrients and sediment that wash into the water from the surrounding land. On their own, they're stressful, but together, they can be lethal. And the really insidious part of this whole thing is how this triad attacks. It doesn't just hit one spot. It hits Manoomin from all sides, targeting it right at the most vulnerable points in its life. To see how this works, we really need to look at the plant's year-long journey from a tiny seed to a full-grown plant.
Okay, check this out. Manoomin is an annual plant, which means it has to pull off this entire life cycle successfully every single year, or it's game over. It starts as a seed in the winter mud, grows into a fragile little seedling in the spring, develops these floating leaves in early summer, and then finally pokes out of the water to flower. A failure at any one of these stages means no new seeds for the next year. The whole population is at risk.
First up, let's talk about our first suspect, wild water. Because of climate change, the Great Lakes region is seeing more intense rain and faster snowmelt. This creates these chaotic, totally unpredictable water levels in the estuary, which is exactly the kind of thing this super-sensitive plant just can't handle. And this chaos in the water, it's just devastating. I mean, think about it. A sudden flood can wash all the seeds away or bury them too deep to sprout. High water that sticks around too long can literally drown the seedlings before they ever reach sunlight. A surge of water can just rip the plants right out of the mud when they're in that fragile, floating leaf stage. Even a sudden drop in water can make the tall plants topple over. One bad storm at the wrong time can wipe out an entire year's crop. All right, suspect number 2, rising heat. The Duluth area has warmed up a lot, and Lake Superior is actually one of the fastest warming lakes on the entire planet. This means warmer water in the summer and milder winters, and that creates a whole new set of problems for Manoomin. So, how exactly does this heat cause so much trouble?
Well, for one, that warm, muggy air is just perfect for fungal diseases that can weaken the plant. The heat also gives a huge advantage to tougher competitors like cattails and water lilies, which can outgrow and shade the wild rice. And weirdly enough, even the warmer winters can be a problem, because the seeds might actually need a really long cold period to get the signal to sprout properly in the spring. And that brings us to the third and final member of this triad, what scientists call toxic pulses. You see, those intense storms we talked about don't just bring more water. They wash huge amounts of sediment and nutrients from farms and cities into the estuary all at once.
And this pulse attacks in a few different ways. The water gets all cloudy and murky, which blocks the sunlight that those little seedlings desperately need to grow. All those extra nutrients are like junk food for algae and those competitor plants, helping them grow fast and choke out the rice. And finally, that fine sediment can literally just smother the seeds and seedlings right there in the mud.
Okay, so a theory is great and all, but where's the proof? Is this actually happening? Well, the evidence suggests we're not just seeing some slow, gradual decline. It looks a lot more like the whole system is falling off a cliff, just like the triad theory would predict.
If you zoom out and look at the whole region, wild rice harvests are dropping every year. And you hear these stories from indigenous harvesters who say they've seen entire lakes just flip. One year they're full of rice, the next it's all gone, usually after a big storm or a really weird summer. And right there in the St. Louis River estuary, even the restoration projects are showing this pattern. A site will be doing great, and then one extreme weather event hits and poof, the rice is gone. So, let's pull all this together. What does it all mean? Look, this is about so much more than just one plant. The disappearance of Manoomin is a message. It's a warning flare from the Sentinel on the water, telling us about the health of the entire St. Louis River estuary. The plant's collapse is what you might call an integrated signal. It's taking in all this stress, the wild water, the rising heat, the toxic pulses, and its disappearance is the clear, unambiguous result. It's telling us that the estuary as a whole has been pushed past a critical tipping point.
And there's this quote from the research paper that just nails it. It says, "Paying attention to Manoomin is not a sentimental add-on to estuary restoration. It is a diagnostic act." In other words, watching out for this plant isn't just about preserving something beautiful. It's a scientific tool. Its health tells us if our restoration efforts are even working, and if the whole system is still in a livable zone. And that really leaves us with one big, pretty sobering question, doesn't it? In a world where our climate is changing faster and faster, this Sentinel is practically screaming a warning at us. It's telling us that the ecosystems we depend on, the ones we thought were stable, can actually collapse pretty suddenly when too many stressors hit at once. So the real question isn't if these tipping points exist, but what is this Sentinel telling us about the future of all our precious waters?